Okay, welcome to this lesson Python, where we shall calculate here the rate of return. Let's see. Let's start with a little theory, something which students of economics should know better than me. So we start with what is the simple rate of return. Well, the simple rate of return is calculated as price at end of the period minus the price at the beginning of the period divided by the price at the beginning. Okay? So if you invest 100, the price becomes 110, it's 110 minus 100 makes 10, divided by 100, you have a return of 10%, so it's a percentage. Okay, well, it can be simplified with price at end divided by price at beginning minus 1. Okay. I hope you have enough mathematical knowledge to understand that it's the same. Okay, well, if you want to be precise, inside this price at end, you should insert all the things that you have gained in the meantime, which, for example, for stocks or are dividends, maybe dividends, for bonds, maybe coupons. So all the extra things that you have earned. However, if you use the adjusted closing price of stocks, as we will, these extra things are already included inside. Okay, this is a simple rate of return. Simple rate of return. Let's make it larger so you see it better. Okay. People who work in finance use also the log rate of return. Common. I will never learn that on the Mac. It's common C and not the log rate of return, which is defined as the logarithm, okay, of the price at end divided by the price at beginning. And I'm pretty sure that you remember here one of the famous properties of logarithm. The logarithm of the division is the subtraction of the logarithm. So log of price at end minus the log of price at beginning. Okay, this is the logarithmic return. Okay. Also here, in this price at end, you should include also the extra things that you earn, such as dividends or coupons if you're talking about bonds. Okay, well, why do we have two definitions of rate of returns? I will be very honest and very rough towards my economist colleagues. Well, I believe only in the simple rate of return, because that's exactly the money which enters my pocket. In my pocket, I get this one. I don't get the logarithm of the price, I get the price. Okay, so I believe in the simple rate of return. That's what my belief. There are, however, theoretical reasons why people use the logarithm rate of return. I investigated around and I found out that people prefer the logarithm rate of return. First of all, because very often this quantity here is normally distributed, while for sure this quantity here is not normally distributed. There is a theory behind which says that the stock prices are log normal. It means that therefore their logarithm is normally distributed. And having a normal distribution of the rate of return allows us to use several statistical tests which have the normality prerequisite. Okay, so this is the first reason, a theoretical reason. The second one is a computational reason. The computational reason is pretty simple. If you have the logarithm rate of return of a period, okay, and the logarithm rate of return of the next period, so for example you have the make it larger. I have the log of end 2006 minus the log of end 2005. This is the log rate of return of year 2006. Okay, Then I have the log of end 2007 minus the log of end 2006. This is the logarithm, log rate of return of 2007. So this is the log rate of return 2006, and this is the log rate of return 2007. Okay, so if you have these two quantities and you want to get for some reason the logarithmic rate of return of the period 2006-2007, what do you need to do? Suppose that you don't have the prices anymore. So the only thing that you have are these two numbers, the subtraction. You don't have the original numbers. Well, you can easily sum up the two things. Log RR 2006 plus log RR 2007. And look what you get. If you sum up the two things, the log n 2006 and minus log x 2006 cancel out. And so what remains is log n 2007 minus log n 2005. And this is exactly the logarithmic rate of return of the period 2006-2007. So logarithmic rate of return are additive. Okay, so if you have a logarithmic rate of return of a period and the logarithmic rate of return of the next period, you can sum them together and get the logarithmic rate of return of the entire period. Okay, this is obviously useful only if you don't have the prices anymore. Well, if you have the prices, well, you can recalculate it using the prices, and that's it. Okay. This, however, is something which you could not do with a simple rate of return. There is a mathematical formula which allows you to combine the simple rate of returns. And let me check whether it's a recording. Okay. There is a mathematical formula which allows you to combine the simple rate of return and get the rate of return of an entire period, but it's not so simple as an addition. It's not so simple as an addition. It's much more complex, and especially it requires you multiplications, and especially it has some computational problems, because when you multiply small numbers, rate of return very often are small numbers. When you multiply small numbers, you may run into computational problem, into rounding problems, and the result may be very far away from what it should be. So the fact that log rate are additive makes it easier for the computer to calculate, to combine several periods together, make it easier for us to write the formulas, and in particular avoids rounding problems which are typical of multiplication, because if you try to do the same thing using simple rate of return, there is a formula which involves multiplication, usually powers, and it's rather complex. Okay. In particular, whenever you talk about a rate of return, you should also specify which period of time are you talking about. Daily, weekly, monthly, quarterly, yearly, or whatever. So usually I will specify every time log yearly rate of return, log daily rate of return. Okay. There is a very handy formula which converts the rate of return daily into a yearly. Okay. If it is log, it's very easy, the formula. If you have a daily rate of return, okay, you just multiply it by 365 and you get the yearly rate of return, the log yearly rate of return. Okay. So can you see the advantage of the log? You just multiply by 365 from the daily and you get the yearly. For the simple rate of return, it's not so easy, because the simple rate of return, you have to add 1, you have to raise to the power of 365, and then you have to subtract 1, and this is the simple daily rate of return, and this is the simple yearly. And this is what I was talking about before, summing up small periods such as 365 days, well, for the log it's easy. You sum up the periods, or if you suppose that they are the same, you just multiply by 365. For the simple year of return, you have to do something much more complex, a power, okay, which can create also sometimes big rounding problems if the simple daily rate of return is very, very small. Okay. However, remember that this is the formula for the log, while this is the formula for the simple. There are people who write simple daily rate of return by 365. That's the simple yearly rate of return. This is only an approximation. It's usually a valid approximation, but sometimes if the daily rate of return is pretty high, it will yield something very wrong. So sometimes people use the formula for the log to convert the daily log into a yearly log. But what? Okay. So sometimes people use the formula for the log also for the simple, but it's only an approximation. Let's write it clearly here. Only an approximation. And honestly, I don't want to see it. Okay. Because if you do something like this in finance, you may, I will show you later, you may lose a 1-2% of yearly rate of return, something unbelievable. Okay. So, let's see now practically how to calculate this rate of return. I have here Anaconda. Let's check whether it's recording. Yes. For this lesson we need to import as usual NumPy as MP. I will zoom. Then from pandas data as usual, it's the usual thing. Import data as WB, and then this is new, import from matplotlib, import pyplot. Well, we will call it plt, or call it whatever you want. Don't call it plot because it may run into problem. So we will import the entire NumPy module. From pandas data reader module, we will import only data, the data object as WB. Sorry, the data function. And from matplotlib, we will import only the pyplot function as plt. Hop, cross the fingers because the import. What is it doing? Okay, done. Okay, as usual, we extract the data from Yahoo. It's the same thing, data read, the same thing we did last time. This time we extract them from Procter and Gamble. Procter and Gamble is a famous American consumer goods corporation. So it's the things that you find in the grocery store, the supermarkets. Data source equal Yahoo. And as usual, start equal 1995 11. Okay, let's see. Done. As usual, we check the head at least. Sorry, oops. The head and the tail. The head and the tail. That's sorry, oops. The head. Okay. Seems correct. The tail. Yeah. Okay. Whenever you do these things seriously, please check also on the web. So here, now currently it's the 13th of March. Its closing price is 101.18. So Yahoo PG price. Procter and Gamble. Okay. No, I don't want to set up Yahoo. Okay, 101.18. the closing price of yesterday, yes, 101.18, fine, so it's correct. Now just to check that you're doing things which are okay. Now you have things in your PG data frame. Okay. We have already seen PG info, head, tail. Let's see some little tools to take data from your data frame. The data frame object is a very complex object. Look, pandas data frame. Just to give you an idea, the data frame documentation. This is the documentation of the data frame object. Okay. These are the parameters to create it, but you have the data reader which automatically creates it. Some example. These are all the attributes. You can see a lot of attributes. Size, shape. We'll see how does IAT works. And these are all the methods that the data frame object has. You can see a ton of methods. You can do whatever you want. Okay. Even though I may say it's pretty confusing because it took me half an hour to discover the things that I will now show you to you. Okay. So let's see how to get data from a data frame. A legitimate question that you should ask me is how do I extract data? Because you can watch them, you asking PG tail, PG head, print PG, but how do you get the data? Well, I found several methods. One is pg.take. Okay, it requires a list of indexes. So for example, 3, 4, 5, 6, 7. You can create them with a range function, for example. Okay. And gives me the third, the fourth, the fifth, the sixth, and the seventh in Pythonic. So it's the fourth, the fifth, the sixth, the seventh, and the eighth. Okay. Daily value, all the values. If you want just adjusted close, you can just adg close. Okay, and you get only the adjusted close. Okay, you can do whatever you want. For example, you want to multiply by 100, done. Can you see this multiply by 100? So you have a sort of thing, object that you may do whatever you want. Okay, so the take is a possibility. In this case, you have to specify the indexes that you want and the column that you want. Okay. Another possibility is the IAT. Pay attention because the take is a method, so it requires round parentheses. The IAT is an attribute. Okay. So alone it doesn't do anything, but if you specify, for example, 3, 2, what is it? This is the row number 3 and column number 2, which is Pythonic, so it's the fourth row and the third column. And just give it a plain number. So it's the day, the fourth, that's it, the fourth day. Where is the head here? 1, 2, 3, 4. And column 2, so 0, 1, 2, 15.15, 6, 25. 15.15, 6, 25. So you can access the items directly. The unfortunate thing is that you must specify the numeric index. You cannot specify the date. And here you cannot specify the adjusted close. You must specify explicitly the column. There is, in theory, another attribute which should work, which should let you do something like this. Okay. Unfortunately, it gives me an error. Okay. It should work. Should give me the adjusted close of the fourth row, but for a mysterious reason. A nice prize to the first one who finds out how does it work, the 80. Okay. You have other ways to extract the things. Look at this strange way. PG dot. Here you can specify the start date. Colon, the end date. This extracts. This is much more useful if you want to work with dates explicitly. This is more useful if you want to work with indexes. It's much more useful if you want to work with dates explicitly. Oops. Okay, sorry, the dot wasn't there. Okay. And what if you want only one date? If you want only one date, for a mysterious reason, it doesn't work. You have to use the .loc. It means local. This works. And if you want only one column, well, the usual trick, a DJ close. Okay. So we have some tools to access directly the numbers inside, because sometimes you need just one of the numbers inside the data frame. These are the little tools to let you access directly the number inside the data frame. Let's now calculate the rate of return. Okay. Let's see how to calculate the rate of return. We'll start with a simple one. You have, you can imagine, a long list of adjusted closing. We will use the adjusted closing price, obviously. A long list of adjusted closing price. The rate of return is calculated taking this value here minus this value here divided by this value here. Oh, sorry, divided by. Oh, you can use the short formula. Let's see. Word. You can use this formula here. Price at end divided by price at the beginning minus 1. So this number here divided by this one minus 1. Okay. How do we do it? Well, there are two ways to do it. The first one is using a for loop, which goes through the entire data frame, row by row, and calculates adjusted closing divided by the adjusted closing of the previous time minus 1. The second way is using vectorization. So we'll start with the first one. So we will have to set up an appropriate structure in which we can put the result of the simple rate of return. We can set up a list, for example, but an array is more efficient. Okay. How do we set up an empty array? We have never done actually it. So we start with setting up an empty array. You set it up empty, just calling empty. Okay. Inside you specify how long it is. It will be a one-dimensional array. The length will be the length of PG. Let me first check what does len of PG returns. Okay, so SR equal numpy empty creates an empty array longest length. Okay, fine. Now SR is an empty type. SR is an empty array. In the numpy and the array, okay, empty, currently empty. Okay, now for I in range so I will iterate over from 1 up to the length of PG. Pay attention that I start from 1 and not from 0, and there is a reason, because if I start from 0, I will now show you why. If I start from 0, I will run into a problem. So SR of I will be equal to PG IAT. So the value in position I, on row I and column 5. 5 is the fifth column, it's adjusted close. And this is the reason why I would prefer that AT works, so I could specify a J close. But unfortunately it doesn't work, so I have to specify the numeric value of the column. Minus divided by the price at the previous time, so I minus 1, 5, minus 1. Okay. And here you should understand why I started from 1. Because if I start from 0, this is the price at 0th row, which is the first one, divided by the price at row -1, which is the last one, which is something completely wrong. Okay, so this is the reason why I start from 1. Okay, so hop. Let's take a look at it. Okay, the first one is 0, because I created it with empty and it's undefined, nobody touched it. The second one is the rate of return between the first and the second day, the rate of return between the second and the third day, and so on. So we have all the rate of return. Okay. There is, however, another way to calculate the rate of return, which is much more efficient, faster, easy to write than a for loop. We use vectorization. Okay. This way also gives you the possibility to put the result directly into the data frame. Look, PG off. Simple return. Simple daily return equal okay. The PG off. Let me IDG close divided by TPG of ADG close dot shift 1. So we have this -1. This powerful method which can be applied to a data frame, shift 1, which means go back of one step. Why it is called vectorization? Because it does everything in a single. It doesn't. I don't use any for loop. I take the entire column of adjusted clause. I divide each element of the column by the element before, thanks to shift 1, and I subtract 1 to each element of the column. So I do an operation which should be done element by element. In fact, here I'm doing the operation element by element. I do it with a single instruction. Okay. Usually this is much more efficient than doing it element. Sometimes element by element is necessary because you have to do peculiar operations for some elements. But if you can, using vectorization is much more efficient and also much shorter to write. You don't need a for loop. Okay, let's see. Hop. Head, no, PG dot head. Simply daily return. Okay. The first one is none, which means not a number, because the shift 1 does not return anything. So the second one, third one, and you can see they are the same as before, 8015. Let's see before, 8015. 01414, 01414. It's the same exactly as calculated before. Okay. The other advantage is that doing this thing here puts the result directly into the data frame, while here puts the result into an array. Okay, you can write PG of simple daily return equal SR, and we'll throw the result from SR into the data frame, but this can directly put the results into the data frame. Okay, you can plot it. PG op of simple daily return dot plot not plt. Okay, if you do like this, it already works, but sometimes it's better to specify fig size, not thing size, which is the size of the picture that you're going to make. I try 15.8. Hop. What's the matter? Fig size is not defined. What is fig size? I hate when... Okay. not specify. Okay. Okay, this is the plot. Whenever it gives you strange... Oops. May I... Okay. Okay, sorry. Plot figure size. Remember, Google is always your friend. Sorry, plot figure size Python, because otherwise Python. Fig size. What doesn't work? Fig size equal 15.8. Okay, well, now it works. Okay, this is the daily rate of return between 1995 and 2019 for Protector and Gamble. Okay, whenever you see a picture like this, you should immediately say something. There's a mistake here. This is pretty unbelievable. Minus 30% on the same day. Well, it can be on the closing price, because maybe a dividend was issued or the stock was split. If a stock is split in two parts, well, each of the new stocks is worth half of what it was before. So a drop of 50%. Okay. But on the adjusted close, this should never happen. Well, don't worry, it's not a mistake in this case, because if you look, this corresponds to the September 2001, okay, the Twin Towers, when the entire stock market went down 30% until it was suspended. Okay, so this is not, in fact, the day after it jumps up, and the day after again it bounces down. A lot of volatility. There was also a lot of volatility in 2010, probably the crisis. Okay, so this is the daily stock return. Sorry, the daily return. If for any reason it doesn't appear, PLT show. Okay. If for any reason the graph doesn't appear, PLT show. If it appears, fine. There are other things you can use. Let me copy and paste. Mean is a method which gives you the average. So we have an average daily return of 0.054%. Okay. Let's see whether we have also median. I'm curious. Yes, also the median stock return. It's not my task to explain you the difference between mean and median. I seriously hope you know it. Okay. Let's calculate now let's go back to the mean. Oops. Given the mean daily return, let's calculate now the yearly daily return. How do we do it? Well, a rough approximation is multiplying this by the number of days that you have. It's not 365 in this case, because you have only the days in which the market is open, so this is not really a daily return, because, well, if it is Tuesday, it's a daily return, because it's compared to Monday, but if it is Monday, it's not a daily return, because it's compared to Friday. Okay. Also, if you are around Christmas or days like that, it's not a daily return. So it's not really a daily return. So you should not multiply by 365 as if it were a daily return, but by 250, because there are approximately 250 days in which the stock market is open per year. This, however, is an approximation, and I tell you, it's a bad approximation. Okay, this is 13%. Let's make it more readable. So by 100 plus percent. Just an aesthetical modification. 13.74%. Oh, we can also round it. Round. Oops, too much. I round it to 4 digits. Okay. 13.75%. This is the yearly stock market return. Okay. Calculated with this bad formula. Let's calculate it with the exact formula, which I gave you before. So the exact formula which I gave you before says raised to the power of 250, not 365. Sorry, before minus 1, and then raise it to the power of 250, and then plus 1. Oops, no, there is a mistake. Let me go back to the formula. Here. Sorry, plus 1 to the power of 265 minus 1. So plus 1 to the power of 265 minus 1. Okay. Look at the difference. It's a 1% point difference. This is the correct formula, which converts your simple daily return into a yearly return, into a simple yearly return. And this is the approximate formula. So please don't use the approximate formula for simple returns, always the correct formula. Okay. You can, in the same way, calculate the log returns. Since I'm particularly lazy, I will go back and just modify the formulas. So I use directly vectorization for the log returns. I don't calculate it using the for loops. So these are log daily returns. How are they calculated? Well, np.log, which is the logarithm, minus np.log, and the minus 1 is not necessary anymore. Okay, the logarithm of the adjusted close minus the logarithm of the previous adjusted close. Up. Let's see. You have it? Yeah. Let's compare them. Can you see they are pretty similar? Logarithm and daily simple return and logarithmic return are very similar if the rate of return is very small. In case where the rate of return is large, they are not so similar. So this is the log daily return. Up. Let's see. Oh, here the drop was more than 30%. Okay, let's calculate the mean. Okay. And now let's calculate the yearly log return. This time it is correct to use the additive formula. Okay. Because as I explained you before, the advantage of using log return is that you can add the period, so you can multiply by 250 the daily return to get the yearly return. Okay, this formula is not for log returns. Okay, you can see that in this case the log return is very different from the simple return. Okay, I think we can stop here with the video. Just a little addition to this video. Well, calculating the having a graph of the rate of return such as this one, well, it's not very informative, even though you can clearly see what happens on a daily basis, but you don't have any idea of the distribution of the rate of return. So together with this graph, it could be a good idea to draw also an histogram. How to draw an histogram? Also, an histogram is pretty easy to draw. So we take simple raw. Okay, this is the, let's check it, yes. Okay, dot plot. Okay, always dot plot, but this time, instead of leaving it like this, we specify kind equal hist. So we specify that we want an histogram. We specify also how many bins. I hope in some statistical courses somebody told you how to build an histogram and what's the meaning of bins and how many to choose. Okay, so don't choose 100 bins if you have only 200 days, because it doesn't make sense. Okay, and then the usual figure size equal 2010. Okay, I think everything is fine. And so it will automatically draw an histogram. The histogram is pretty unbalanced because there is this minus 0.3, which is the, yes, the Twin Towers event. Okay, but let's see. I am curious what happens if I restrict removing the twin towers event. So from here I put dot lock, and starting from 2011 up to nothing. So let's see whether it works. Yeah, it works. So I managed to remove the twin towers event, and here you have. Okay, same thing with the other one. So now I just copy the instruction. Go here. It was log roar. I also here removed the twin tower event. Okay, and you can see that it's honestly very symmetric. So the difference between the negative return and the positive return on a daily basis, it's really marginal. So you can see it only from the descriptive statistics that the difference is positive. Okay,